Hi, my name is Erin Spencer. I currently work in the NIU STEM Outreach Department. Today we're going to do a fun experiment from the Howtoons book involving making a balloon rocket. All you need are a balloon, some string, a straw, some tape to put your pieces together, and some object that will allow you to clamp your balloon shut without tying it. I like to use these binder clips. And some scissors to cut your straw up. The basis of your balloon rocket is really simple. You're going to start by inflating your balloon and you're going to secure it with the binder clip. Don't tie it in a knot. So you're going to take the scissors, it doesn't need to be exact, and just cut a piece off. You don't need the rest of it. Now you're going to take one side of the balloon and you're going to place the straw on there and you're going to secure it with some tape. So I secured one side of my string to one side of the room, and I'm about to secure it to the other side of the room. It doesn't need to be very tall. You're going to put the string through the straw on your balloon. It doesn't really matter what side it goes through. And then you will lift your rocket into the air and attach the string up to the other side of the room. And that way you've got your balloon rocket on its track. Let's set our rocket into motion. All I'm going to do is release our binder clip and we'll see what happens. Yay! The rocket is a really good demonstration of Newton's 3 laws of motion. So Newton's first law is basically saying that an object in motion will stay in motion and an object at rest will stay at rest unless they're acted upon by an outside force. Right now my balloon is kind of just sitting there, and as soon as I allow the air to release, that's going to act as a force basically propelling the balloon forward. I used kind of a really slick, smooth string. The reason I did that is because friction is a force, and in this case the friction between the string and the balloon can actually slow your balloon down, so that is an outside force. But we're going to skip Newton's second law for a moment and move to Newton's third law. Newton's third law is for every force there is an equal and opposite force. So I mentioned that the force coming out of the balloon is the reason that the balloon is propelled forward. So the air moves backwards from the balloon, and so then the balloon moves forward as the air exits. So that is an illustration of Newton's third law. And basically all you need to do is take a paper clip and just open it up, just like that. So I'm going to take my paper clip and I'm going to actually attach it to the bottom of my balloon. Newton's second law of motion basically states that force causes acceleration where mass opposes acceleration. So my balloon, when I release the binder clip here, Newton's third law gets set into motion. That's the force, basically, the force propelling the balloon forward. So that's the first part of Newton's second law, that the force will cause the acceleration. The second part is that mass will oppose the acceleration. And an easy way to demonstrate that is then to hang various items from this paper clip, the idea being the heavier it is, it should oppose the acceleration, it should move slower. So that's how we use our balloon to illustrate the 3 laws of motion. Once you've got the base of your balloon rocket built, you can test to see what happens when you add different amounts of air to the balloon, you add different masses to the balloon, and see who can maybe make it a competition and see who can build the fastest rocket.